Yes. Okay, we're all set now. So the next, basically, what is this? Holy, holy. All right. So last thing we're going to do in this chapter, well, it's not the last thing. We have done the we have done discharging. I believe we have done RC. We have discharging curves. I think we are almost done. We just need to do one more thing and then we're good to go. Okay, let's have a look. So now we're gonna start off with calculating the capacitance of a hollow metal sphere. All right, and this derivation is included in the course, and this will be asked to you very often. So what happens is that we already know from the previous chapter, the electric fields, that in a hollow sphere, the charges basically are on the surface, like that. Is that PDF editor पे जा full Mac के लिए मैथ के लिए पीडीएफ एडिटर वो मिला के चलो वो शॉर्ट कर यार अच्छा उस पे देखो ना क्या कहते हैं उसमें उसका ऐप स्टोर पे देखो जरा ऐप स्टोर पे देखो कौन सा हाईएस्ट आ रहा है अगर खरीदने हो कह रहा खरीद लो ओके नाउ then r is the radius of this. Let's look at that. So we know from the previous chapter that the voltage or the potential at the surface is going to be kq over r, right? From this chapter, we have learned that q is equal to cv. Everybody agrees? So what I'm going to do is I'm going to put basically I got to remove this v, okay? So I'm going to put this value right here. If I do that, then it's going to be q equals to c times kq over r, just like that. Q and q is going to cancel out. So I'm going to get r equals to c times k, and c will be equal to r over k. You guys get it? Please look at it. And now check this. K is going to be 1 upon 4 pi epsilon. So if I put it right here, it's going to be C r upon 1 over 4 pi epsilon. This goes up. So it's going to be 4 pi epsilon times r. So the capacitance will be like that. You guys get it? So this is the final safe thing that you guys need to do. I hope that's clear. Okay, write it down, please. Okay. Now I'm gonna basically go through one more thing that I believe might come in your exam as well. They haven't given it, but it might. So let's do that. You guys done? Should I go forward now?
Yes.
Okay. So what I'm saying is, let's write here time taken for a capacitor. Okay. Time taken for a capacitor to discharge to half of its energy, of half of its charge. Doesn't matter. Okay. Now let's have a look. So we are gonna basically compare two different capacitances. Okay. So we are gonna take one capacitor as a 1500, about 1,000. So we have two capacitors because discharge of capacitors is a new topic. It's basically not much information about it is available yet. There's just one exam about it or two maybe, and we still need to figure out. So one capacitor is 1,000 microfarad, and the other capacitor is basically 2,200 microfarad. So these are two capacitors that are available. Okay. Now we say let time t half. It's not basically, we're not halving time, it's just in the subscript. Okay. Let time t half the time taken for a capacitor to discharge to half of its initial value. This is what you're looking at. All right, kids. Now think about this one. So suppose we take the simple equation V equals to V naught E minus T upon RC. Basically, you can use any value. Okay. And here we have basically a circuit shown. Let me show you the circuit as well. This was 12 volts. This was the capacitor that we need, that we put. This is the resistance R, and the value of this resistance is given as 1.5 kilo ohms. All right, we can either put capacitor A or capacitor B in that space. Okay. Now, first of all, we will be doing it for 1000 microfarad, right? We can put the values. V equals to V naught E minus. We're finding this T half. Is it clear, everyone?
Yes.
So divided by RC. So the total voltage was 12. So it means I'm going to put 12 and we're checking how much time does it take to reach half of its value. So minus T half divided by RC. So then 6 over 12 will be equal to E T half divided by RC. T half is just the symbol. And then you got to take ln. So this will come as T half divided by RC times ln E, like that. We already done that, so you guys know. Now let's find the value of this. So ln 0.5 is going to give me minus 0.693 minus T half over RC. Now R is 1500 because that's the value of the resistor, and the capacitance is 1000 times 10 raised to minus 6 because it's 1000 microfarad. Half and half will cancel out. So the time it will take to discharge this, it was 15,000. Sorry, I did 1.5. It's 15. So because that would be very small. 15. Okay. Now, so I'm going to do 0.9693 times 15,000 times 1000 times 10 raised to power minus 6. So it's going to give me about 10.4 seconds of discharge time from 12 to 6. You guys get it?
Yes.
Good. Then for the other one, I'm going to use another color. So for 2200 microfarad, let's do the same thing. V equals to V naught E minus T half RC. This will be 6, this will be 12, this will be T half and RC. This will be ln 6 over 12 and this will be minus T half over RC. I'm skipping some steps, but I hope you guys understand. If you get confused at any point in this, do let me know, okay? Now, what you do next is that you, this is just one. So this will be minus 0.693. This will be half. This is 15,000. Now this is 2200 times 10 raised to a minus 6. Now, so T half is going to come as 0.693 multiplied by 15,000 times 2200 times 10.10 minus 6. So it's going to give you about 22.9 seconds. Is it clear, everyone?
Yes.
Good. So if I basically make a graph of these two, let's draw a graph here. So this would be voltage in volts, this will be time in seconds. So basically both graphs should start from the same point. One graph would look like this. The other one would look like this. Okay, let me tell you how. Now we're starting off with the same voltage initially, and we're reaching at 6. So you might see that the one that reaches 6 in less amount of time, which was 10.4 seconds, the other one reaches, oh no, it's not even a straight line this guy. The other one basically takes about 22.9 seconds to reach here. So this one is 1000 microfarad capacitor. This is 2200 microfarad capacitor, right? So in comparison, we could say that actually the conclusion of this is that the discharging time depends on time constant, which is equal to the factor of RC, right? So you had the same resistances, but as you can see, that greater the value of R into C, the larger time, longer time it would take to discharge. So, an important point here, either increase the value of resistance or capacitance to increase discharging time. Is it clear, everyone? Please have a look. Let me know
Yes.
if you have a question here. So this is something very important to understand, that why this factor RC is so important. Okay, good. Abdul Rahman, Abu Bakr, Aisha, everybody understand this? Tanya, Afan, why are people missing today in the class? The other Khatija is not. Is Zainab, Samir, Khatija, and Javeria, Huda, everything is clear?
Yes, sir.
Yes, sir.
Alright. So this marks the end of this chapter, which is good. So now we can basically focus on the worksheet. Yay! Alright. The previous worksheet is already pending because,
Funny story about that, sir.
yes.
Turns out I actually did do that worksheet, but I forgot to tell you that I submitted it.
Oh, okay.
No joke, you can check the submission date.
Okay. But that's good. That's very nice. But what about the other 16 people in this class? What are they doing? Nobody's
Sir,
doing.
I also submitted the worksheet.
Also submitted. Very good. Excellent job. And Abu Bakr,
आज
yes,
शाम तक कर
aaj sham ko. Okay. And Dania and Aisha and Javeria and Khatija and Sameer. What about you people? Abdurrahman?
It was me, Javiria, who said that I submitted.
Okay, okay, sorry. Yes, and Zainab. Sorry, I wanted to say that. Okay. So that's good. That some of you have done it. Now I'm going to give you another worksheet. We wanted to, let me see. I discussed electric field already, I think, you know. I've done that, I believe. Okay. Abdul Rahman is here. Abu Bakr has promised. Okay, thank you. So I've checked all of this work yet, which is good. I've not left anything. Now I'm going to go to the next worksheet. The next worksheet is a very interesting one, the capacitance one. So let's have a look from where I can give you that worksheet. An easy one or a hard one? Let me see. A2. Also, I wanted to basically tell you something important. I think you will be able to wait. Temperature, capacitance, and capacitances. The issue with this is that I don't want to basically send you. This is a quite easy one, I think. It's not a basically big worksheet. Let me check the energy one, please. And this basically also marks the end, like almost we are done with 60% of the syllabus, which is a very good thing. It's nice. Okay, I'm sending you this one. This is much better one. Okay, wait. Energy. Oh, sorry, capacitance. Okay, now I believe that you guys are now grown up, and I can trust you people because you've been submitting worksheets now. So I'm sending you the whole topical PDF. Okay, just remember it's not for you to share with a lot of people. Just share it with yourself. And now, what I expect from you people is that you will be solving questions from these topicals whenever you want to, and you will ask me questions from it. That okay, sir, I was solving this chapter and I felt that this question is difficult. Can you please help me with that? Because then I will know that you're studying. And if you do like one question like every day, it's not a hard task. Okay, I sent it. You can download this, by the way. And when you do, it basically has a lot of questions. Just I want to tell you few things that are out of syllabus now because this topic will hold some other questions as well. Let me just show you. Okay, wait. Oh, it's there. It's not. The chapters that you don't have to do are basically you will not do communication. That's out of the syllabus. You will not do electronic and sensing devices out of the syllabus. Rest of it you will have to do, but then there are few other things that I want to tell you. In few things that now you don't have to do are MRI. MRI is out of the syllabus as well, so don't do that, please. I don't think so. Everything else is like there, so you can do that.
Okay.
I think that's it. All right.
Okay, can you send this in the classroom as well?
Yes, I have sent it in Google Classroom. You can download it. This is for you to practice on your own because
No,
obviously
I
I
meant the image of what is excluded.
you the topics are this is complete book. The topics that are excluded now are topic 20 and 21,
All right.
topic 16, and MRI if it's anywhere in the book. Is it clear?
Yes.
Good. Now, then the next content that I'm going to share it with you is from another board. Wait a second. Now, unfortunately, like I said, discharging capacitances just came in your um, course, so we got to basically practice it from Edixel. They have it for a very long time. I'm sending it to you, this worksheet. Let's save it. Okay. So, discharging of capacitors practice. Okay. This worksheet you can also do in your free time. Just try to manage this, please. Here, from Edixel. Okay, so for now, what you're gonna do is the worksheet that I've assigned. Yes. Okay, thank you. Fun. For now, the worksheet that I've assigned, you guys need to start that. You got to start from this question. I'm just here. The moment you feel that okay, you do not understand something, you can't do something, just ask me. I'll help you with that. Okay, it's a small worksheet. Only I think only 11 pages. You can do that now. Please hurry up. Okay, continue please doing this. Let me know if you have a question at any point.